Okay, so this is a lesson on binomial expansion. All right, so what we're going to do today is learn how we can use something called Pascal's triangle and binomial expansion to multiply binomials. This is a bit of a shortcut. So when we talked about multiplying polynomials, we know that x plus y squared really means x plus y times x plus y. So then I want to distribute this and figure out what I get. So I would go x times x, which is x squared. Then we go x times y. So I'm going like this, then like this, right? First, x times y would be xy. Now I'm going to go this times this, and then this times this. So that would be y times x would be, I'm just going to write it in alphabetical order, so that would be xy. And then y times y would be y squared. Okay, so now the two terms in the middle, I want to combine those. So I would have x squared plus 2xy plus y squared. Okay, so that would be my answer for x plus y squared. So how does this work? So if I have to do this for, now you can see this next one here, it says x plus y to the third power. Well, I'm going to give myself a little bit of space by erasing this. Okay, so I just did x plus y times x plus y. But I know that this is x plus y times x plus y times x plus y. Okay, now I know that when I do x plus y times x plus y, I get this right here. So I can replace this first part with that answer. This looks a little weird. Okay. Now, in order to figure out what my answer is for x plus y to the third, I need to bring this part down and multiply and figure out what I get. Okay, I'm going to give myself a little extra room here. All right, so what does that mean? Well, I want to take x squared times both of these, and then I'm going to do this times both of these, and then y squared times both of these. So let's do that. So x squared times x is x to the third power. X squared times y is x squared y. Okay, now I'm going to do 2xy times both. So I have 2xy times x would be 2x squared y. And then 2x squared y times y would be 2xy squared. Okay, and then y squared times x would be xy squared. And then y squared times y would be y to the third. Okay, so now I'm going to combine some like terms. So I have x cubed, and now I'm going to put this together with this. So that's 3x squared y. And now this and this. That would be 3xy squared, and then y to the third. Okay, so this would be my answer. Now you can start to see as we raise exponents on this, this becomes pretty big pretty quickly and can take a while. So what we're going to learn today is rather than doing this every single time, is there a little bit faster way to do this? And there is, but it follows a certain pattern. So that's what we're going to talk about. Okay, so we're going to look at kind of a pattern that you'll see for x plus b to the 0, x plus b to the first, x plus b to the second, to the third, to the fourth, to the fifth. Okay, so First, though, we're going to talk about something called Pascal's triangle. And Pascal's triangle is really just a triangle with ones on the outside. So I'm going to start with, let's go to a different color here. We'll start with 1 here. Okay, and what happens is you have ones on the outside. The next row is going to have 2 ones. And then ones on the outside. And now I'm going to add these 2 numbers here. 1 plus 1 is 2, and that's going to go in between. Okay, so I got ones on the outside. I'm going to add 1 and 2 here, and 2 and 1 here, and write those underneath. So this would be 3 and 3. And I'm going to just continue this. One's on the outside. 1 plus 3, 3 plus 3, 3 plus 1. We'll go in those slots right there. So this is 4, 6, 4. And then my last would be ones on the outside. I'd have 5, 10, 10, 5, 1. This is called Pascal's triangle, and you can just continue that pattern all the way through. Okay, so we're going to use this fact to help us do binomial expansion. Okay, now, a plus b to the 0 power is just 1. Anything to the 0 power is always 1. A plus b to the first power is a plus b. A plus b to the second power looks like this. How do I know that? Well, we just kind of did that up here. We did x plus y squared, and we got this answer right here, which you'll notice looks the same just with x's and y's as what I just wrote here. Now we just did to the third power with x plus y to the third power, and we got this thing right here. So now if I just copy that, but put in a and b instead, you'll see I have this. Let me get my pen going. There we go. A to the third. I'm just copying what we had up top. Okay, now I'm going to continue this, and I'm going to just kind of expand these and show you what you get. And then we're going to see if we recognize a pattern. So a plus b to the fourth power would be this. Oops. All right. And then a plus b to the fifth. I'm going to need to write this probably pretty small so I can fit it all in here. Let's see if we can do that. Looks like I'm going to be able to fit it in here. Okay, so we get this, and this is called binomial expansion. Now you'll see a plus b to the fifth power, I get a massively large polynomial there. And so if we start having exponents bigger than 5, we're going to end up spending a lot of time. Now, if you were to do x plus b, or a plus b to the 5th power, you know, that's writing it out 5 times. So you're ending up with a lot that you have to do. And you can only do 2 at a time. So that's going to take you some time. You're going to have to multiply these 2. Then once you get that, multiply it by this. Once you have that, then multiply it by this. Then once you have your answer for that, then multiply it by this. This will take you a while. But there is a pattern. And so on this next slide, I have it a little bit cleaner. So you'll notice a couple of things. First of all, on the right-hand side, let's use a different color here. On the right-hand side, Pascal's triangle are the coefficients of every term. So what do I mean by that? Well, let's take a look at this line right here, okay? Notice here, the coefficients of this polynomial are 1, 3, 3, 1, which matches what we see here, okay? So that's important, okay? And then if we looked at the next line, we'll see that same pattern. So the next line says 1, 4, 6, 4, 1. If we look over here at this polynomial, you'll notice 1, 4, 6, 4, 1. Okay? They match. Okay, so now that is true every time. All right, so then the next thing that you want to look at, and maybe the easiest place to tell, is the very last line. So I'm going to start there. We know that we have these coefficients, which you'll notice are all on the left here. But then we also have this. If you look at this first term, this is a. It's raised to the same power. It's a to the 5th. Okay? Now look at the powers on a as you go to the right. It's 5, 4, 3, 2, 1, and then it's gone. There isn't one. It's 0. Okay, cool. So it starts at 5 and goes down to nothing. Look at B. B is the second one here, right? It starts, there isn't one here. It starts at 0, B to the 0, B to the 1st, B to the 2nd, B to the 3rd, B to the 4th, B to the 5th. It's going up by 1. Okay, so what is happening? We have our first term starts with the same power. In this case, it was a to the 5, and it works its way down. Okay? Then the second term starts at 0, okay, and goes up, right? It's going up throughout there as you go to the right, okay? So that's the pattern that we're gonna use to help us try to do some of these problems, okay? And we're just gonna use both Pascal's triangle and this binomial expansion pattern. So let's try it. This will make it a lot faster to do these. So the first thing that you want to do and how we can apply this, so let's say I have something like k plus 5 to the 4th power. The first thing you want to do is identify on your sheet to the 4th power what the coefficients are. So here's to the 4th power. You're going to look at the coefficients. They are 1, 4, 6, 4, 1. So we are going to write on our problem, I'm just going to write it right here. 1, oops, help if I had the color. There we go. 1, 4, 6, 4, 1. Okay, now I have that written there. So I'm going to put those numbers in front of each term. Okay, then next, I know that my first term should start with a power of 4 and work its way down. Okay. And then the second term should start with nothing and work its way up. Okay, let's see if this makes sense. So we're going to do 1k to the 4th will be my first term. I'm not going to put the 1 in there in front, but you know that that's really a 1 here. Okay, so that's my first coefficient. Now 5 is not going to go here because it's 5 to the 0, which is not going to be written there. Okay, plus, now I want to put my next coefficient is 4. Put a 4 in front. Now this will be k to the 3rd, 1 degree less. And now here, I'm going to have 5, and it's going to be 5 to the first power. So I'm going to put it in parentheses. You can write to the 1 if you want, but I usually don't. Okay? And then plus, now I'm going to start with my coefficient 6. Now this would be 6k squared. And now this would be 5 squared. Okay, so remember, the 5s are going up by one degree. So we got k, or 5 to the nothing power, 5 to the first, 5 to the second. Okay. Now the next one would be 4, and then k to the first, or just k, and then times 5 to the third. Okay, plus 1, I'm not going to write the 1 in front. K is going to be k to the 0, so that's gone. And then 5 to the fourth. So just double check. Do I have 1, 4, 6, 4, 1 in the front? Yes. Okay. All right, next. I want to start with k to the fourth to the third squared. First, nothing. Does that happen? Yes. Okay. Now next, my second term should start with nothing. Nothing here. To the first power. To the second, third, fourth. Okay. Cool. So when you get good at this, you'll just write this right away, and you'll do that. And now all we have to do is simplify. So k to the fourth, I'm just going to do some multiplication, keeping in mind PEMDAS. So this first term, k to the fourth, is just going to come down. Now, the next term, I can't do anything with k to the third, but I can multiply 4 times 5. That is 20. So this would be 20k to the third. Okay, cool. Then here, remember PEMDAS says I need to do exponents before I multiply. So I can't do anything with k squared, but I want to do this first. 5 squared is 25. So I'm going to say I need to take this, 25, and I have to multiply it by this 6. So I want to do that 5 squared first though, which is 25. So I'm going to take my calculator and go 25 times 6, right? Or do that in your head. You get 150. So on here, I'm going to write 150k squared. Okay. Remember, do that exponent first before you multiply by 6. So same thing here. I want to do that first. So 5 to the third power. Again, if you're not good with that, 5 to the third. So 5 to the third is 125. Now, I have to multiply that, and you noticed I have to multiply by 4. So I have 125 times 4. Okay, cool. Times 4, I get 500. All right, so I'm going to write 500k. And then this one, I have 5 to the fourth, so I'm just going to do that on my calculator. 5 to the fourth power, 625. Okay, so this is plus 625. And now I have my answer. And you're done. Now, if you do k plus 5 to the fourth and expand it, and don't do this binomial expansion way that I'm showing you, it's going to take you probably about 10 minutes. Once you get good at this, it'll probably take about three-ish minutes. But when we go through it the first time, it's kind of weird. So we're going to practice this a couple more times, and then that'll be it. All right, so this next one has a negative in there. It's just something to be aware of. When you do these problems, again, don't forget you got to write your Pascal's triangle numbers first. So I need to, this was to the fifth power, so I'm going to need this line right here. I'm going to need those. So I'm going to write 1, 5, 10, 10, 5, 1. And I like to write it just up top here. 1, 1, 5, 10, 10, 5, 1. All right, now I'm gonna go through this one a little bit faster, but we're starting to the 5th power. So I'm gonna say m to the 5th. Negative 8 will not be there. Again, think of this whole thing all together as a negative 8, because that negative 8 will start at 0. And so, okay, next, put the coefficient 5 in front. 5 m to the 4th now, times negative 8 to the 1st. So I didn't have a negative 8 here. It was to the 0 power. Now it's to the 1st power. Plus 10, writing that coefficient. M to the 3rd. Negative 8 squared. Plus 10 m squared. And then negative 8 to the 3rd. Okay? Plus 5 m, and then negative 8 to the 4th. Okay? And then I'm running out of room, but I'm going to put it underneath here. Plus, then negative 8 to the 5th. There will be no more m's because it's m to the 0 on that one. Okay, cool. So now you're going to do your simplifying, and hopefully this will come across pretty fastly. You can see this is going a lot faster already. M to the 5th. Simplify. I want to simplify this. I want to do exponents first. Well, I can't do anything with m to the 4th, but I can do something with the negative 8 and the 5. So negative 8 times 5 is negative 40, and then m to the 4th. Plus, now I want to do this first before I do times 10. So negative 8 times negative 8 is positive 64. So I'm going to have 64 times 10, which is, 640 m to the 3rd. Okay, and then I want to do this next term. I want to do negative 8 to the 3rd and then times 10. So when you do negative 8 to the 3rd, make sure you put it in parentheses, negative 8 to the 3rd power. And we get negative 512. Now I'm multiplying that by 10, remember. So I get negative 5,120. Okay, so negative 8 to the 3rd was negative 512. And then times 10. Am I right? Negative 5,120 m squared. Okay, now I'm doing negative 8 to the 4th power first times 5. I don't know why this keeps zooming out or zooming in. So negative 8 to the 4th power is 4,096. So I would have 4,096 m. And lastly, I want to do negative 8 to the 5th. And that is negative 32,768. That's right. Okay, and that is my big, long polynomial that we just did. If you did this problem, x or m minus 8, and then wrote that out 5 times and multiplied it, this would take you a lot longer. So this does help. It just is interesting and sort of weird at first. Okay, so the last thing that I want to go over is a problem where you have a number in front, and this does make it more complicated. So let's try it, give it a shot. It's not too bad. It just takes a couple things you just have to be careful of. So first, it's to the 4th power, so I'm going to write out my coefficients, and then we're just going to get started. So it's going to be 3x to the 4th. But notice this time you're going to have to put that 3x in parentheses because you're raising that whole thing to the fourth power. So we're going to talk about that a little bit more here in a second. And we won't have negative 6 yet, but then plus 4 as a coefficient, right? And then 3x squared, or to the third, excuse me, and then times negative 6 now to the first power. We did not have a negative 6, now it'll be to the first power and then the second, etc. Plus 6 times 3x squared times negative 6 squared. Okay? And then plus 4 times 3x times negative 6 to the third, and then plus 1, 3x will disappear, so times negative 6 to the fourth power. Kind of starting to run out of room. Okay, now we are going to simplify this. So when we simplify this, 3x to the fourth, remember this really means 3 to the fourth, x to the fourth. So you're going to have to figure out what 3 to the fourth is. So 3 to the fourth is 81. So just simplifying this part, you don't want to just write 3x to the fourth. That will be wrong. It's actually 81x to the fourth. So this 81x to the fourth plus, okay, now I want to do this first before I multiply everything out, times 4 and times negative 6. So this 3x to the third is really 3 to the third x to the third. Okay, 3 to the third is 27x to the third. So 3 to the third, 27. So now I need to take 27 times 4 times negative 6. So that's what I'm going to do on my calculator. 4 times 27 times negative 6. Negative 648. And then x to the third. Okay, so I'm just going to go through that whole process again. Here I have 3x times 3x, or 3x squared. That would be 9x squared. So now I got to do also this one. So negative 6 times negative 6 is 36, positive 36. So now I have 6 times 9 times 36. Okay. $1,944. That would be positive. And then x squared. Okay. Now this one, I just need to do this, and then I can multiply by, there's no exponent on 3x, then I can multiply by 3 and 4. But let's see, negative 6 to the third power is negative 216. And then I have to multiply that. So this is negative 216. I need to multiply by 4 and 3. Okay, so times 4 times 3. Negative 2,592. X. And then lastly, I have negative 6 to the fourth power. Which is 1296. Okay. Okay, we just did that, and here's our big answer again. with lots of large numbers. Just make sure that when you do these, you take your time, go through each part, and you are using order of operations, and you should be fine. Hope that makes sense. All right, take care.